All right, good day, Dina and Jada. Um, Today we're going over organic chemistry. Um, well, I'm saying good day, Dina and Jada, but I'm literally just talking to myself because y'all are not here. Ah, so we're going to do organic chemistry today, and organic chemistry. This lesson is going to be coming from page 92 in your textbook. Okay, so when we hear when we think of when we think of organic chemistry, basically organic chemistry is the study of carbon-based matter, right? So as the book, so of course what organic chemistry basically is. So organic chemistry or OChem is the study of carbon-based matter. That's really what organic chemistry really is. And so you would ask, okay, so where all could carbon be? I mean, so you would ask, okay, where all is this carbon found? And this carbon could be found, but most of these carbon is found in fossil fuels, crude oil, um, natural gas like methane, right, and coal. So they're all fossil fuels, and the fossil fuels are formed from the remains of dead plants and animals. All right. So this unit is going to be basically focused on crude oil, which is petroleum. So this unit focuses on crude oil. It focuses on alkenes and mainly alkenes. So alkenes. So canes and kenes. It doesn't really focus on alkynes that much, and it doesn't really focus on aromatics that much, right? Aromatic compounds like benzene. It doesn't really focuses on that heavily. So when we look at um, crude oil is important, um, and the materials are obtained by two processes, right? So the first thing is with crude oil. Crude oil, we of course we get crude oil from the ground, deep in the ground, right? So they basically mine for oil. That's why oil is so important in so much countries like oil, right? Because oil is so useful. And so in a process called fractional distillation, we basically can get various compounds or various alkenes from crude oil, right? And how we get it is we know that distillation, you separate, well, in fractional distillation, you're separating a mixture, right? By heating and then condensing. And with fractional distillation, it's when it condenses according to the difference in boiling points in the boiling points of the liquids in the mixture. And so with fractional distillation, you have like your big, of course, you can have your different fractions. You have your different fractions, all right? I'm using this line to represent fractions right here. And so as you go down, you have a high temperature, right? And as you go up, you basically have gases as you go up. So like your refinery gases, right? Like your butane or such or so. But as you go down, the carbon chain actually gets longer. And so as you go down, you maybe at the bottom, you'll have your bitumen that's used for roads. actually, let me show you an example of a fraction distillation. Let me just go to my screen and show you an example of what I'm talking about. Let me just do that. So if I type in fractional distillation, and let's look at this. All right, so if we look at this, or even this right here, notice at various temp, where is it? Well, if you go here, right, you notice with fraction, it's distillation by separating crude oil. Notice like what you have. Of course, as you go down, it gets hotter, and you can see that by the red. And you have the residue used to make bitumen, asphalt, that's in roads. And then you have fuel oil used for big ships, right? Lubricating oil, diesel, kerosene, naphtha, used in chemicals, petrol, and refinery gases used as fuel, right? And that's so yeah, and that's like a liquefied petroleum gases. So that's just basically fraction distillation and crude oil, right? But let us, and then of course there's something else. So, but what I want to get into firstly is I know the book have it so kahonkalapi, but the first thing I want to let's do is something called let's understand a term that's called homologous series. And homologous series, basically, it's as the book have in page 92, it is a family of compounds which have the same functional group. And when I say functional group, that is stuff like alcohol. So for an example, you have something like this, right? First, you have your H's. You have your H's. You have your H's. And right here, you have an OH, alcohol, right? So this is a functional group right here. And homologous series is a family of compounds which have the same functional group, right? They have similar chemical properties. So the BGCSE may ask you about 4 properties. So one, about homologous series. Homologous series have the same functional group. They're gonna have the same general formula, similar chemical properties, as well as, and next thing you could say is a gradual change in physical properties. A gradual change in physical properties. Now, what I'm going to get into now is the need of what y'all really need to know about this organic chemistry. And the first thing we're going to look at is alkanes. And the general formula for alkanes, notice I'm saying general formula. Well, I wrote this bad. Let me write this again. Alkanes. We're gonna look at alkanes. So the general formula for alkanes is CN. C starts with carbon, H, 2N plus 2. And alkanes by itself, well, yeah. So alkanes have the general formula CN, H2N plus 2. When I say general formula, I mean it shows the exact number of atoms. So it shows the exact number of atoms of each element. That's what general formula. So right here, this is the general formula. For alkenes. So if you have N, means number of carbons. So if you have C3, what you do is you take that 3, you see where N is, you substitute it right there, put 3 there, and you multiply it. This parenthesis means multiply. 3 times 2 is 6, plus 2 is 8, H8. So how the name goes is like this. This is how it goes. It starts with meth, in. That means 1 carbon. Then the next, you have meth, ethene. Then you have propane and butane. It's 1, 2, 3, 4. Then pentane. Then you have hexane, heptane, and so forth, octane, nonene, decene, and 11 is, I think 11 is maybe dodecene, and 11 is, and I think 12 is maybe, can't remember what 12 is, right? But this right here means it has 1 carbon, 2 carbons, 3 carbons, 4 carbons, 5 carbons, 6 carbons, 7 carbons, 8 carbons, 9 carbons, 10 carbons, 11 carbons. Now, I believe 12 is undecene, but let me verify it now. No. So 11 is undecene. 11 is undecene. And 12 is, so 12 is dodecene. So math is 1. So based on the formula, based on this formula right here, it'll be C. And if it's 1, you put 1 there. So it'll be H, 2 times 1 is 2, plus 2 is 4. So it'll be C, H, 4. And notice I don't put a 1 there because it's already only 1 carbon. Ethene, eth is 2, F is 2, C, 2, put a 2 there. Let me put a 2 there. 2 times 2 is 4, plus 2 is 6. H6. Propane, C3. H, put a 3 there. 3 times 2 is 6, plus 2 is 8. H8. Okay? And this is important. This is important to know because what the book, I mean, if you, in terms of reactions of alkane. So alkanes can undergo certain reactions. Alkanes can undergo certain reactions. So, of course, we're still talking about alkanes. And certain reactions that alkanes can undergo is one is a combustion. So one is combustion and incomplete combustion. And the products of combustion, the products would be carbon dioxide and water. Incomplete combustion would be carbon monoxide and water. Notice the big difference. So for an example, if I have methane, what is the formula for methane again? What is the general formula? Because remember, general formula means it shows all of the atoms that belong to each element. Remember, general formula shows all atoms. General formula is different from structural formula. So when I say general formula, meaning something like this, ACH4 for methane. Structural, you put a C there, and then it's 4 H's, right? This would be the structural formula. So the structural formula, as it states, structural formula shows the bonds present in the molecule. So structural formula shows bonds present, and general formula shows all of the atoms in that belongs to each element. So carbon is will have 1 atom. Hydrogen has 4 atoms. 4 atoms. Okay. So let's go back, sorry. So if I want the general formula for methane, it'll be CH4. And how did I get CH4? Because C, alkanes, remember the formula for alkanes is CN H2N plus 2. So if I want methane, it's 1 carbon, put a 1 there. 2 times 2 is 2 plus 2 is 4. 2 times 1, sorry, is 2. All right? So methane, if it is a combustion, or incomplete combustion, what you must know is that it is going to react with oxygen. It's going to react with oxygen to produce what are the products? Carbon dioxide and water. So we look to try and balance this equation, what you would find out is that this is 1. So if you put CHO and CHO on this side, this is 1, there's 1 carbon. How much hydrogens on this side for the reactants? 4. O is 2. On this side, 1. Hydrogen is 2. O is 3. So what if I put a 4 here? If I put a, well, not a 4, sorry, 2. If I put a 2 here, on this side, it means this now, hydrogen now changes to 4, and oxygen changes to what? 2 plus 2 is 4. So let's see if it balanced. 1, 1, 4, 4. Oops, 2, 4. This needs to be 4. So if I put a 2 here, 2 times 2 is 4. So this is balanced. So this would be the combustion equation, right? And of course, a combustion, delta H is negative because this is exothermic. Exothermic means it releases heat, right? So yes, it releases heat. All right. Incomplete combustion. incomplete combustion means it doesn't have, so for an example, let's just say I have ethene, C2, how much H's will I have? If I put 2 here, that's 2 times 2 is 4 plus 2 is 6. So C2H6 plus, let's just say this radius would be the complete combustion. This would be the complete combustion. Plus O2 is going to give me what? Carbon dioxide and water. If I balance this, we have 6H, and on the side, we have 2H. If I put a 3 there, 3 times 2 is 6. Okay, but how many carbons? I have 2. And on this side, I only have 1, so I put a 2 there. Now, how many oxygens would I need? That's 2 times 2 is 4. 4 plus 3 is 7. So I need to put so I mean this 2 times 2 is 4. 2 times 6 there is 2 carbons. I could actually put 5 over 2 here. Sorry, not 5, because it's 4, 5, 6, 7. I could put 7 over 2 there. I could do that, or I could just do this, or I could just put 6 here, 4 here, and 7 here, and 2 here. So this would be the balance equation. Incomplete combustion doesn't have sufficient oxygen. So I put it back here. 2 is incomplete combustion now. Incomplete. So if I put 2 carbon 6, H6, ethene, plus oxygen, it's incomplete. So it's going to produce carbon monoxide plus water. We know monoxide is a very toxic gas. It combines, it replaces oxygen, binds on hemoglobin, reduces the blood's ability to transport oxygen throughout the body, right? And so oxygen here would be 5, carbon monoxide is 4, and this is 6. So if you notice the difference is this have 7 oxygens and this have 5. So it's incomplete, doesn't have enough oxygens. And so that's why it's going to produce carbon monoxide. So some more reactions of alkanes that we're going to see. So we're still on alkanes. So it's something called halogenation. And this is going to happen via in the presence of light. Halogenation. So in halogenation, in the presence, so if we have, let's say, methane, CH4, right? If you react this with bromine, Br2 gas, in the presence of light, let's say UV, bromine splits, and when it splits, what it does is it adds 1 bromine to this. So where you see CH, remember this is CH4, right? This is CH4. And what basically happens is bromine in the presence of light is gonna split. So that'll be 1 electron is gonna go there. And then 1 electron is gonna go here, half out. So you're gonna have Br dot. And so what happens is this goes here and this comes here. So what they actually form is I mean, in a nutshell, you'll have CH. Of course, you'll have a CH radical, but in a nutshell, you'll have CH3 Br plus HBr. Halogenation in the presence of light. And this would be methyl bromine, right? Or bromomethane. Sorry. Sorry, bromomethane. And the same thing can happen with chlorine. If you have chlorine, Cl2, which is the same thing as this, Cl bonded to another Cl. And of course, let me show these electrons here so you don't get confused. Right? And there's one, right? One there, one there. So let's do this again. So in the presence of UV light, I remember we're dealing with just alkanes, halogenation, reaction number one. Sorry, this is reaction number two we're learning about. All right, in the presence of UV light, an electron goes here, one goes here, and we're gonna have Cl with one unpaired electron, and then you have good old CH. Sorry, good old CH, 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 CH. You're gonna have something like this. Bam, bam. So it's going to form CH3Cl, right? So the reaction would be, the reaction basically would be methane, CH4, plus chlorine, Cl2 gas, diatomic, produces CH3Cl plus HCl. And that would happen in one of the propagation steps that you're not going to learn about in in GCSE. Okay, so we learned two reactions in alkanes. The first reaction we learned about was combustion, and we learned about incomplete combustion, and we also learned about halogenation of alkanes. Big difference of alkanes. Notice with alkanes, only one bromine is added. All right. So uses of alkanes. So one use of alkane is alkanes burn as fuel. So let's look at some uses of alkanes. So one use is so if we look at uses of alkanes, one use would be burnt, as the book has it, burnt as fuel to produce energy. And for example, methane, ethane, methane, etc. Second use of alkane is it is used to produce heat. Right? So it's used to produce hydrogen gas via heat forming, right? H2 gas. So via heat, steam reforming, right? And then the catalyst would be nickel. So you produce hydrogen gas. And so an example would be CH4 plus water produces H2 gas and carbon monoxide. And then, of course, but yeah, you know what? That's all I need to know about. All right. Now the book then goes on and they want to talk about something still on the alkanes. They want you to know about something called isomers. So isomerism. And what that word basically means, it's just different forms. So it's different forms of a molecule. But the book's definition, what they want you to know about isomers, they want you to know that isomers are compounds which have the same molecular formula, but different structural formulae. This is the definition that they want y'all to learn, right? And so for an example, you have, let's just say you have butane. Butane, of course, means 4, right? So it's C4, and we're talking about alkanes. Remember the general formula is CnH2n plus 2. You put a 2 there, you get 4. Sorry, it'll be 4. 2 times 2 is 4 plus 2 is 8. So butane is this. And of course, you have 8 hydrogens. So basically, they want you to know this can be written as this, not written, this can be drawn as something else. And that's why we call it an isomer. Because we can write this, this is just a straight chain, alkene. We can write that as this, C, 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 and put a carbon right there. This is actually interesting because it's actually, when you get into higher chemistry, this is actually called, this is an isobutyl group, or this is, I guess they call it isobutane. Oh, sorry. Yeah, I guess isobutane. So you have your H's here still. So this is an isomer because this is a different way, a different way to actually draw your structure. This is a different way to draw your structure, right? So that's a different way. Another way we could have done this is we could have probably put C on this carbon right here. We could have probably did this, C, 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 and then put this right here, put it right there. All right. You could have also done that and put in your hydrogens. Okay, and so the book wanted you all to know about isomers. So what we learned so far, so let's do a quick recap of what we learned so far. A quick recap. So far we learned about, organic chemistry is a study of carbon-based matter. How can we find carbon? We can find carbon as crude oil. We can learn as crude oil, right? So this is a quick recap. And crude oil is basically a formation of hydrocarbons. And this fancy word, hydrocarbons, just means hydrogen and carbon only. That's what that means. Only. Hydrogen and carbon only. So we know we can find these carbon containing compounds as crude oil as coal. And remember where we use coal for. We actually use coal as our formation of carbon when we looked at the blast furnace. And we see that coal was actually a raw material. It was what? It was coal, hematite, coal, hematite, and then limestone rock to remove the sand, right? The silicon dioxide. So we saw coal, and then if carbon is in coal, carbon is in crude oil, and then of course natural gas like methane. So we learned that. Then we learned about basically fractional distillation. We learned that fractional distillation basically crude oil or petroleum can be separated according to that when they condense their various liquid boiling points. So we learned about crude oil and fractional distillation. Then we went on and we learned about the formula for alkane, right? Alkane, remember, if it's an alkane, we know that it's what? Only has single bonds, no double, single bonds, right? Then we learned about homologous series. Homologous series basically talks about a family of compounds with the same functional group like alcohol and stuff like that. Homologous series. We learn about properties of homologous series. For an example, same general formula. We know it homologous series, again, what it is. It's a family of compounds that have the same functional group. Or FUN, functional group. Same general formula. Gradual change in physical properties. Same chemical properties. So those were some things we learned about a molecular series, same chemical properties. Okay, then we learned about alkenes. We know that an alkene has the formula CnH2n plus 2. Again, of course, it only deals with single bonds. And then we went in to learn reactions of alkenes. And those reactions were halogenation, combustion, incomplete combustion. And then we learned about isomerism. Okay, so that was alkenes. Now we're going to go on to those of alkanes. Now we're going to alkenes. Now we're going to go on to alkanes. So the big difference between alkanes, the big difference is that alkanes are single bonded, but alkenes are double bonded. Another difference is, well, we call this double bonded unsaturated. We call that double bonded. We say that it is unsaturated. All right. And so what we want to know is the general formula is also different. The general formula is also different. So the general formula is for alkanes is CnH2n. And the ending, it ends in ENE. So remember in alkanes, the ending was A and E. Now alkanes, the ending is E and E. So you will have methane, sorry. You'll have methane, you have ethane, ENE. You have propane, ENE. Now, okay, now if we want to look at the formula, math means what? One. So C, well, the thing about it is you can't have methane. That makes no sense, to be honest, because it's just one carbon. So that makes no sense. Sorry about that. That makes absolutely no sense. It's just one carbon. So where in the world that double bond could go? H can't have two double bonds. Like that's a no-no. So that's totally wrong. So we start off with ethane, propane, sorry, propane is 3, 4 is butane, Butene, right? ENE, ENE, ENE. Okay. C2, put 2 where N is, and you get 2 times 2 is 4. H4 is the general formula. Remember, general formula shows all of the atoms bonded to the element in the molecule. Propane is 3, and so C3, if you put a 3 there, you get 3 times 2 is 6, H6. Butene C4H8. So let's look at the reactions of alkene. Of course, one reaction is the same as alkene is combustion. So if you add oxygen there, you're gonna get carbon dioxide and water. You're gonna get carbon dioxide and water. So this one here, we're gonna get carbon dioxide and water, right? And of course, if it's incomplete, it would produce carbon monoxide. So this is complete. And if it's incomplete, it will produce carbon monoxide and water. Now, guess what? There's also halogenation of alkanes, but there's a big difference. And this difference, they call it, okay, do they want you to know about that? Yes, they want you to know about it. So we have a lot of reactions with right? The first reaction we have with alkanes, and this can be found on page 96, is we have halogenation again. And this is also, this reaction of ethane and bromine water is also the test the test to see if it's an alkane. So for an example, if you have C2H4 plus Br2, right? It's going to give you C2H. Where you have 4, you just need 2 Br there, right? And so what you get is, hold on, if you do this, so you'll have C, hold on 1 second. Right, CH4, Br2. So notice the formula stays the same, and you add 2 bromine. And it's because hello? Give me 1 second. Hello? Who keep flashing their light? What is Richard? Okay, I'm back. So basically, you're gonna learn this. You get into AP chemistry, but you have your 2 carbons, right? And then remember, carbon only wants to be bonded by 4 things. 1, 2, 3, by 4 bonds. 1, 2, 3, 4. This have 1 H. This have 1 H. It has 4 bonds plus Br. So what technically happens is this happens. You don't have to learn this reaction. You don't have to learn this. Don't have to learn that. That happens. And this happens backwards. So what you end up having is really and truly is something that looks like this. That's H, that's H, that's H, that's H. You end up with something that looks something like this. Sorry. Sorry about that, but you end up with something like this, Br and Br. You're gonna see this when you get into AP chemistry. Don't worry about that part right now. Okay. Yes. Okay, so what the GCSE wants you to know is that for the test for alkenes, you need to know that when bromine water is added, so you need to know that alkenes decolorizes. COLORIZES decolorizes bromine water. All right, so you need to know alkenes decolorizes bromine water, and that's the test. So bromine is a bit orange brownish color, and when you add it, it goes from that brownish color to colorless. And that's how you can tell the difference between alkenes and alkanes. All right, that is how you can tell. Drive safely. That is how you can tell the difference. So that is the first reaction you need to know. Remember the big difference. Remember the difference was for alkanes, ALKANES. When we look at halogenation, it only added 1 bromine, right? So it was C2H6, right? But in the presence of light, Br2 gas, in the presence of UV light, only one bromine added, right? So C2H 5Br, right? Only one added. That's important. That's important to know. All right, that's the difference. So this, look at the difference between this and the difference with this, right? Big difference. The second reaction you need to know is the reaction between KMNO4, potassium permanganate. All right. And so we use again C2H4 plus potassium permanganate K, which is an oxidizing agent, KMNO4. Right. What you're gonna get is something. This is ethene, right? Gonna get ethylene glycol. So C2H4 OH plus MnO2. This is ethylene glycol. And of course, this is a brown. Right? So this would be this solid right here. Brown precipitate. This would be manganese oxide. Brown precipitate. Okay, now the other reaction that they want you all to know about is called hydrohalogenation. And so the other reaction they want you all to know about is hydrogenation. And all that is again, if you so is it, I don't see it here, so I doubt you to learn about it. It's not in this book. It's not in this book, so you don't have to know about hydrogenation. It's not in this book. Hydrogenation though. They want you to know about hydrogenation. All right. And so hydrogenation basically is adding hydrogen. So of course we're still on alkanes. They want you to know about hydrogenation. Right? And so for an example, if you have a C2H4 again, and you would act with hydrogen gas with a Nicholas catalyst, Ni, what's going to happen is it's going to add two more H's. So you will have C2H6. So for an example, if you have this right here, you have H, you have H, you have H, you have H, you have H. If you react H2, what it does is this bond removes. So one H is going to go there and one H is going to go there. And that's how we got C2H6. Okay. They also want you to know that this is also called an addition reaction. And it's also used to produce solid margarine from unsaturated liquid oils. So like, you know, butter is at room temperature, right? It's solid because it's saturated, and So right, this reaction could be used to get to do that. The vegetable oil, which is a liquid in your house, it's unsaturated. Unsaturated means it has what? A double bond. And so if you treat it with H2 gas, you can turn it into solid butter or margarine, right? Yeah, margarine, sorry. They want you to know about hydration. So how do you get alcohol? Now you can get alcohols two ways. You can get alcohol by fermentation, right? Using yeast as a catalyst. So if you have glucose, right? You can use sugar. You could use so if you use yeast, right? You could produce alcohol, and that process is known as fermentation, right? Where an organism, right, converts a carbohydrate into an alcohol or an acid, right? And the other way you can get alcohol is if you use hydration. So again, if you use C2H4 ethane, which is ethane, and you react that with H2O and maybe a catalyst of your chosen, like silicon dioxide as a catalyst over 300 degrees Celsius, you can get ethanol, C2H5OH, and that is ethanol. Okay? And yeah. So another thing they want you all to know about with alkanes is that, this is where we have our plastics. This is where we make plastics, right? So what can happen is, let's just say you have ethane again, ethane, which is C2H4, right? So that's our monomer. You take the C, you put the two C's here. Don't put no double bond, right? And then you put your H, make sure that it's straight. It's supposed to be straight now, right? Straight. And then you do a line out like this, and then you do this. And this would be, put your N there, and this would be your polymer. And N just means different, this could be it's a polymer, so it could be up to like 50,000. And so this is your polymer. All right. And this is, so polyethylene. So if you want to do one with butane, or other butane, let's just say you want to do one with propane, you would have to, propane is, remember ethane is C, C, H, 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 and propane, ENE is ENE is C, 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 H, 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 H. What you will do is, again, you could put your C there, and next C. This time, though, you put your C up top here, right? You want to make sure that is is straight. So put your CH3 there, put your H there, put your H there, put your H there. And then if you do that out, you put your line there like this. And this would be, oops, this would be a polypropane. Right? The book wants y'all to know that uses of alkene, of course, it could be used in plastics, production of ethanol, right, from ethene, right, hydration, and then production of PVC, polystyrene. Okay, we're soon finished. If we go and talk about alcohols, you just need to know alcohol is when you have the OH added, OH added, right? So if you have, of course, to make alcohol, again, I told you earlier, fermentation can be used. And I told you about the other way. So of course, alcohols could be combustion again. So if you have C2H5OH plus 3O2, right? This is a combustion. You get carbon dioxide, and you get water. Another reaction of ethanol is oxidation, and that's also important. Now, oxidation basically means if you take this alcohol C2H5OH, and you react that with, let's just say, O2 gas. Normally, you could have as well as KMNO4, PCC, or any one of those as well. What you can get is you can get CH3 CH3COOH, which is ethanoic acid. C3. Let me do this again. Let me write this again. CH3, sorry. COOH plus water. And ethanoic acid looks like this. C. And what happens is that C is bonded like this. This is the acid right here. And remember, this is also, so this is a carboxylic acid, and this is also a functional group. It's a carboxylic acid. Right? You could also use sulfuric acid to dehydrate an ethanol. So for an example, C2H5OH. If you use sulfuric acid, H2SO4, you get H2SO4, you can get C2H4 plus water. Notice C2H4 is the alkene, KLENE, also known as ethene. Okay. Again, carboxylic acid right here. If we go into a reaction of carboxylic acids, carboxylic acid, they are weak acid. It's weak, so it has maybe a pH of maybe 3, right? Right. And if we reacted with sodium, so if you have CH3 COOH plus you of sodium, you can get this replaces the H, so you can get and these are basically, you get a salt, right? You get a salt, right? You get sodium ethanoate. NaCH3COO plus hydrogen gas. Okay. And uses of carboxylic acid, vinegar, right? Food preparation, also used for cleaning, right? The acid, so in preparation of food and bacteria and stuff. And so another acid you always hear about, you always hear about antacids, right? Antacids, basically when people say acid reflux or chest heartburn, they use an antacid. An antacid, like for an example, the buildup of acid can result in discomfort or experience with stomach disorders or whatever. And so if we have an antacid, we need something that ant means against acid, means something to neutralize acid, so we can use base, right? So we can use base. So an antacid, so we have antacid pills when you have heartburns. You can use something like magnesium hydroxide, because you know that an acid plus base equals salt and water. Right? And so when we talk about fuels, well, when we spoke about hold on, give me 1 second. Let me go back up here. When we spoke about alkanes, one thing I forgot to mention something called cracking. And cracking basically it cuts basically long chain, how the book say it? I guess it cuts long chain, I guess I'd say hydrocarbon, but I want to use, let's see what the book has. Yeah, long chain hydrocarbons, they use hydrocarbons. Remember, hydrocarbon means hydrogen and carbon only. So it cuts long chain hydrocarbons into shorter chains. And we have a temperature, I think the temperature is about 600 degrees Celsius, I think they use. And you could use aluminum oxide or even silicon oxide. So the catalyst could be Al2O3 or it could be SiO2. And so what basically happens is, an example is if you have C10H22, right? Cracking always gives you an alkene plus alkane. All right, and so alkane could be C8. You always need to make sure the carbons add up now. So you need two more, right? So this is the alkane, C8, H18. How do we get 18? 8 times 2 is 16 plus 2 is 18. Remember the formula for that is CnH2n plus 2, right? And then the alkene. So we need plus C2 because it's 10. And if it's an alkene, it'll be H4. And that's cracking. We spoke about, getting fuel and stuff. What makes a good fuel? Fuels must be easily burned. So what makes a good fuel is it must be easily burned. So what makes a good fuel? One, easily burned. Two, it must not produce a lot of waste. Let's see what the book. Let's see what the book has. It must be easily burned and produce large amount of energy, and also it must not it must not produce a large amount of waste product. And three, it must be manufactured cheaply. Now we have some disadvantages. So that's fuel, right? Now we have some disadvantages and advantages of using alternative sources of energy. So for an example, with all this fossil fuel going on, we know that at the end of the day, we need to cut down on greenhouse gases for global warming. So what we could do is we could use things like, nuclear energy, wind power, solar power. And of course, if we use nuclear energy, surprise a lot. It's a nuclear energy gives off a lot of energy. For example, uranium. So we could use well, before I go on to that, continuing on to this fuel thing, I know that long time ago, well, they used to use leaded fuel, right? Like lead, PB, and it was not good. It's very toxic to babies, produce a lot of brain damage and stuff. And so they don't use leaded fuel anymore. What they do now is to use an alternative source of fuel. And that alternative source of fuel that could be used could be like hydrogen, like other than unleaded fuel, you could use stuff like hydrogen, ethanol, that kind of stuff, because lead was toxic. Very, very, very toxic. All right. And it's not good. It's not good. And so it's been it's been associated with heart problems and all sorts of issues. And so they use now hydrogen gas or renewable energy for fuel. But when we talk about renewable energy, it's, you know, it have disadvantages and advantages. And like if we talk with nuclear energy, we get energy from uranium. And the bad part would be like nuclear waste, right? If you use solar power may be very, very expensive, right? And so, and of course, if you use a solar panel, the sun needs to be out. So that is it for organic chemistry. And I hope that you, this video was quite long, but I hope that you learned something from it. Okay.